13,000 feet above the sea. Here, in the barren, wind-swept altiplano of modern Bolivia, a vast, high-altitude plateau. One of the most hostile environments on Earth, the air is thin, and the sun is brutal. This is the roof of the world. And here, near the shores of Lake Titicaca, mainstream history tells us a civilization emerged, known as the Tiwanaku. From roughly 500 to 1000 AD, they built an empire. They were a people of the high desert. They had no wheel for transport. They had no system of written language. Their most advanced tools, according to archaeology, were stone pounders and simple, soft bronze chisels. They built a great ceremonial city, Tiwanaku. It is impressive, monumental. We can see how they worked. We see the rough-hewn blocks, the clear marks of their primitive tools, the massive statues. It all fits. It makes sense. Music shift. A low, ominous hum begins, until you walk 10 minutes away, until you arrive at a site that refuses to fit, a site that shatters the timeline. A place called Puma Punku, the door of the Puma. This is not Tiwanaku. This is something else. Puma Punku is not a collection of temples. It is a field of absolute, incomprehensible chaos. 100-ton blocks of red sandstone and gray andesite, scattered like a child's forgotten toys. It looks less like a ruin and more like the wreckage of a catastrophic explosion. But the chaos is not the glitch. The glitch is in the details. Forget the 130-ton blocks. Forget that they were quarried from sites up to 50 miles away and dragged uphill to an altitude of 13,000 feet. Look closer. We are told the Tiwanaku built this site, but the stones themselves tell a different story. This is diorite. This is andesite. On the Mohs scale of hardness, a 1 to 10 scale ranking mineral resistance to scratching these stones, andesite and diorite register a 6 to 7. They are as hard as, or harder than, modern granite, and significantly harder than steel. The tools of the Tiwanaku were stone hammers and bronze chisels. Bronze, a soft metal, has a hardness of 3.5. Let us be clear. This is not difficult. It is not time-consuming. It is physically impossible. It is the equivalent of trying to cut solid granite with a soft copper pipe. But even that is not the glitch. The glitch is this: the H-blocks. Dozens of them. Identical, modular, interlocking. They are not just cut. They are milled. The surfaces are polished to a near-mirror finish. The angles are not just sharp. They are perfect. 90-degree internal corners. Look at these grooves. They are fractions of a millimeter deep, perfectly parallel, running the entire length of the stone. And look at these holes. They are not just drilled. They are complex, countersunk, and spaced with a precision that, to a modern machinist, looks familiar. This is not craftsmanship. This is manufacturing. This is not the work of stone hammers and bronze chisels. This looks like the work of diamond-tipped saws, precision grinders, and computer-controlled milling machines. This is the Puma Punku Glitch. We have a site dated to a pre-industrial civilization that appears to contain evidence of post-industrial technology. One of these things is wrong. Either the dating is wrong, or our understanding of technology is wrong. This discrepancy creates an immediate conflict, a collision of two opposing narratives. The first narrative is from orthodox archaeology. The argument is one of time and patience. The Tiwanaku, they argue, were masters of stone. They did not need advanced technology. They had something more powerful, generations of manpower. They would have slowly, painstakingly pounded the stone into shape. Using harder stone tools, like diorite pounders, they could theoretically, eventually, create these forms. The laser-like grooves. That, they say, is the result of abrasion, rubbing the stone with sand, water, and leather cords, back and forth, for decades. The precision, just the result of a master artisan's eye, honed over a lifetime. In this model, Puma Punku is the ultimate testament to human ingenuity and patience, a marvel of primitive methods pushed to their absolute limit. It sounds reasonable, until you show the H-blocks to a 21st century engineer or a master stone mason. They don't just disagree, they laugh. They laugh because they know what it actually takes to do this. And it isn't a stone hammer. This brings us to the alternative hypothesis. The argument is one of technology. This hypothesis states that the evidence is exactly what it looks like, the product of an advanced technology, unknown to the Tiwanaku. This theory branches into two main paths. Path 1. The Tiwanaku did not build Puma Punku. They found it. They inherited it. This theory pushes the site's origin back, deep into prehistory, to a lost, global, technologically advanced civilization. The same civilization, some argue, responsible for Göbekli Tepe, or the foundations at Baalbek. In this model, Puma Punku is a legacy site. The Tiwanaku simply built their own city around this impossible, ancient machine shop they could not comprehend. Path 2 is even more controversial. It suggests the technology wasn't cutting. It was molding, drill through one of the hardest stones on Earth. Archaeology suggests they used a simple bow drill with a bamboo shaft, sand, and water. But the evidence in the holes contradicts this. When a simple abrasive drill is used, the resulting hole is tapered. It's wider at the top than the bottom. And the drill core, the piece left inside, is also tapered. The holes at Puma Punku appear remarkably uniform in diameter, challenging the typical tapered results expected from a simple bow drill. Furthermore, microscopic analysis of the drill cores reveals tiny, equidistant striations, grooves running down the core. This evidence. The equidistant striations, the uniform bores, has led engineers to a disturbing conclusion. This does not look like a human hand. This looks like a constant, mechanical feed rate. This looks like a machine. This leaves us with two conclusions, both of which are revolutionary. When we investigate Puma Punku, we are not just looking at a ruin, we are analyzing a process. Let's begin with the material itself, andesite. This volcanic rock is notoriously difficult to work. It is brittle. If you strike it too hard with a hammer, it doesn't chip, it shatters. The idea of pounding it into shape is difficult. The idea of pounding it into a complex, thin-walled H-block seems impossible. Any mistake, one single misplaced strike, and the entire 20-ton block would fracture. Yet, we see dozens of them. Perfect. This suggests a process that was controlled, predictable, repeatable. This is the definition of manufacturing. Now, let's look at the cuts. The abrasion theory, sand and water. This method works. We know ancient cultures used it, but while abrasion can shape stone, it naturally rounds edges. To achieve a sharp, perfect, internal right angle, combined with a mirror-flat surface and millimeter-thin parallel grooves, simultaneously, using only sand and leather, strains credibility. The grooves are even more problematic. They are often less than a millimeter wide. They are perfectly parallel. Sometimes they stop and then start again, exactly in line. An engineer would call this an interrupted cut. It's a hallmark of a powered, guided tool, a saw or a router that is lifted, moved, and placed back down on the same cutting path, trying to achieve this by hand, rubbing a string back and forth for years. While maintaining that level of perfection, it defies logic. But the most compelling evidence, the smoking gun of Puma Punku, are the drill holes. We find holes drilled through solid diorite. Some are small, complex, like channels cut into the stone. Others are a series of holes, drilled in a perfect line, to create a perforation to knock a section of stone out. This is a modern quarrying technique. How did a civilization with no metal hard enough to drill through one of the hardest stones on Earth? Archaeology suggests they used a simple bow drill with a bamboo shaft, sand, and water, but the evidence in the holes contradicts this. When a simple abrasive drill is used, the resulting hole is tapered. It's wider at the top than the bottom. And the drill core, the piece left inside, is also tapered. The holes at Puma Punku appear remarkably uniform in diameter, challenging the typical tapered results expected from a simple bow drill. Furthermore, microscopic analysis of the drill cores reveals tiny, equidistant striations, grooves running down the core. This evidence, the equidistant striations, the uniform bores, has led engineers to a disturbing conclusion. This does not look like a human hand. This looks like a constant, mechanical feed rate. This looks like a machine. This leaves us with two conclusions, both of which are revolutionary. The conclusion: the primitive Tiwanaku possessed an extraordinarily advanced understanding of physics, geometry, and engineering, one that we today cannot replicate with their known tools. They invented a method of working hard stone that is now completely lost to history. Conclusion B: the Tiwanaku did not build this. They were settlers in a junkyard of the gods, the remnants of a civilization so old their timeline doesn't exist in our history books. The geopolymer molding theory tries to split the difference. It provides a primitive method, mixing materials to achieve a high-tech result, molded blocks. But this theory has its own problems. Where are the molds? Where are the mixing vats? And analysis of the H blocks shows they are, indeed, volcanic andesite, not a man-made cement. The evidence consistently points back to cutting. The evidence points to machines. This brings us back to the ruins, the chaotic field of impossible blocks. What happened here, Puma Punku, does not look finished. It looks like a factory that was shut down, catastrophically, mid-production. We see blocks with the initial cuts started, but not finished. We see H blocks stacked, as if waiting for shipment. And then, silence. The official narrative states the Tiwanaku Empire collapsed around 1000 AD, possibly due to drought and climate change. The city was abandoned. But this doesn't explain the violence of the site. The blocks look blasted apart. Did a cataclysmic flood, an earthquake, or something else strike this place? Did it strike the Tiwanaku, or did it strike the original builders thousands of years earlier? This is the timeline glitch. For decades, we believed civilization started around 4000 BC in Sumeria. Then, we found Göbekli Tepe, a complex, 12,000-year-old megalithic site built by primitive hunter-gatherers. Göbekli Tepe proved that our timeline of social development was wrong. Does Puma Punku prove that our timeline of technological development is also wrong? We are left with a site that should not exist, a collection of stones, cut with a precision that would challenge a modern factory, allegedly made by a culture that lacked the wheel. Puma Punku is an anomaly. It is a data point that breaks the entire equation of human history. It forces us, as the honest broker, to ask the forbidden question, are we, the first industrial civilization on this planet, pause? Or are we simply the most recent?